Have you ever heard of the simulation theory? Popularized by the movie The Matrix, it actually has roots in physics. Discoveries in the quantum world have drawn many theoretical physicists to the idea that matter is not fundamental, but emergent from quantum interactions, that the physical reality we interact with daily may not be what reality actually is. Discoveries like Pauli's exclusion principle, the idea that electrons cannot occupy the same quantum state, paint a different picture of what physical reality truly is. Rather than holding something, what you feel is the electron clouds of your finger repelling the electron clouds of the object. As we've established in quantum field theory, reality is not made out of tiny billiard balls, but of underlying fields that permeate everywhere, even in empty space. From the layers and patterns of reality, we see a constant projection of new forms, all emerging from the same probabilistic quantum soup. So we ask, what are these layers really? Are they an illusion? Why is there a direction towards greater forms, where creation constantly scales upward? It seems that reality itself may be a projection, a hologram of a more fundamental essence, where everything we perceive is a derivative of something deeper. Welcome, conscious colleagues, to the Philosophy of Power, a movement dedicated to uncovering the secrets of reality and the power of consciousness. In today's episode, we continue our ongoing series on the architecture of reality. This is part one of a two-part exploration of one of the deepest questions our framework has led us to. What is reality actually made of? In part one, we follow the science, we examine how information precedes matter, explore the implications of the holographic universe, and ask whether the layers of reality we've been mapping are projections of something more fundamental. In part two, we'll bring it back to the framework, connecting projection to transcendence, to the direction of creation, and to what it means for us as conscious participants in this process. But first, the question that started it all: is all of reality an illusion? Information as fundamental and matter as projection. From an early age, we were taught that the world is composed of separate things with their own intrinsic qualities, that everything was matter and nothing else. For a while, this was a useful map. Reductionism, breaking things down to their smallest parts to understand the whole, helped us uncover many secrets of reality. But this mechanism dug so deep that it began to challenge our most basic assumptions. Before the discovery of the quantum world, atoms were thought of as theoretical at best, a neat mathematical trick, or at worst, mere philosophical speculation. Scientists at the time held a strict empirical bias. Prominent figures like physicist Ernest Mach and chemist Jean-Baptiste Dumas argued that since atoms could not be seen, assuming their physical existence was unscientific. This wasn't a fringe opinion, it was a worldview deeply held by the scientific community. Austrian physicist Ludwig Boltzmann, who pioneered the statistical physics of atoms, was widely ridiculed and ostracized by the establishment precisely because his theories depended on their existence. Impossibility is the enemy of progress. Thanks to Albert Einstein and the founders of the quantum realm, Max Planck, Erwin Schrödinger, Niels Bohr, Wolfgang Pauli, Werner Heisenberg, Louis de Broglie, and Paul Dirac, we now know that atoms are not only real, but measurable. And with that confirmation, our picture of reality changed entirely. This shift did something more profound than add a new entry to the periodic table. It cracked open the assumption that matter was the ground floor of existence. If the solid, touchable world dissolves at the quantum level into fields and probabilities, then what is actually fundamental? This is the question that consumed physicist John Archibald Wheeler for the latter half of his career, and his answer would reshape how we think about reality altogether. Recall the measurement problem in quantum physics. Before measurement, a particle is in superposition, acting like a wave, spreading across all possible states at once. But once measured, it collapses into a single definite outcome. Wheeler took this further by asking, if observation is what collapses possibility into reality, then reality isn't pre-existing and waiting to be discovered. Observation creates existence. He called this the participatory universe, where the universe requires participants, observers, to bring it into being. No observation, no definite reality. But Wheeler wanted to go further. What happens if you delay the observation until after the particle has already passed through the slits? Instead of placing the measurement device before the slit, it's set up at the finish line, and a super-fast mechanism switches that finish line mid-flight. Option 1. A photographic screen captures the photon as part of an interference pattern, proving it traveled as a wave through both slits. Option 2. The screen drops at the last millisecond, revealing two telescopes aimed at each slit, and the photon travels to only one, proving it passed through as a particle. The choice made at the end determined what the particle had already done. The present reached back and rewrote the past. This led Wheeler to his most radical conclusion. It from bit. Information comes before matter. If a measurement at the finish line can collapse probability into reality, then the universe isn't a machine made out of stuff. It's a vast informational process, and matter is its output. Every physical property, mass, charge, spin, position exist only as potential until an exchange of information makes it definite. This is exactly what quantum field theory confirms. Particles are not fundamental objects, but excitations of underlying fields, and those fields, at their core, are information. Think of it like the letters of an alphabet forming words. Everything you touch, hold, feel, and build is information locked into a specific local configuration, letters arranged into meaning. But here's what makes reality stranger than any language. The letters themselves are not fixed. They have no definite form until the moment of interaction. The alphabet of reality is written in the act of reading it. Reality doesn't exist and then get observed. It gets observed and then it exists. This goes back to what we mentioned in a previous video. Reality is not a thing. It is a process of being. Projection of information. If the bedrock of reality is simply fields of information, then what is the physical reality we experience daily? Let's go back to the cinema. When you watch a movie, you perceive a vast three-dimensional world on the screen, but in truth, all that depth is an illusion coded into a flat, two-dimensional sheet of projected light. This is exactly how the macroscopic world behaves. because it is a projection of the underlying information fields that constitute reality. As particles are derivative of fields, so is every configuration of matter in existence. Zoom in into any single object, a cup for instance, and you wouldn't find separate solid parts, but a fuzzy sea of probabilities. Our experience of the three-dimensional world is simply a projection of the two-dimensional quantum realm. This idea is called the holographic principle, formulated by Nobel laureate Gerard Hoof and expanded by Leonard Susskind, one of the founders of string theory. The principle states that the description of a volume of space can be fully encoded on a lower dimensional boundary of that region. Picture a three-dimensional room containing everything: atoms, matter, gravity, living beings, quantum fields. According to the holographic principle, everything happening inside that room can be perfectly calculated by reading the flat, two-dimensional information encoded on its walls. This holds in the quantum world. The quantum fields and their interactions do not actually vibrate through deep three-dimensional space. Mathematically, the fields interact and exchange information on a two-dimensional boundary. The solid three-dimensional matter we experience in everyday life is the holographic projection generated by that exchange of information. The principle remains hotly debated, but black holes offer the most compelling hint that it may be correct. In our three-dimensional experience of reality, storing more data in something requires increasing its volume. Common sense. But the universe doesn't work that way. Imagine a massive pile of computer hard drives into a three-dimensional room. Gravity takes over and collapses it into a black hole. When physicists calculate the absolute maximum data capacity of that black hole, they find the limits is defined not by its three-dimensional volume, but by the two-dimensional surface area of its outer event horizon. The universe refuses to store more information in the three-dimensional interior and instead spreads it across the two-dimensional exterior. This means everything we experience is a projection of an underlying universal source of existence, and that includes us. We are expressions of the fields, the units of being, the eyes through which reality sees itself. We are not made out of blocks that stack. We are projections of fields and energy. Through this frame, we no longer see ourselves as separate. We are the vessels of the universe's ongoing project of becoming. The insistence of existence. If everything is a projection, how do things feel solid? Reality is filled with compact, tangible forms, and all our experience reinforces the feeling of a physical universe. But remember, this is because of specific principles in the quantum world. If electrons could occupy the same quantum state, we would all collapse into a formless mush, unable to hold anything. The projection has to be reinforced with layers of patterns, threads of certainty that allow information to be structured. Each layer produces its own projection, a new state of existence not found in the layer beneath it. Every time reality projects itself, there is novelty, not just endless repetition. Reality evolves with each new projection, reinforcing the entire structure as it climbs. Projection, then, is a form of spreading existence into a new level, constructing a more insistent reality where stability maintains the form of projection. But if a projection loops into stagnation, entropy breaks the cycle and allows a new projection to emerge. In our daily lives, a projection is a trick of perception, creating what looks like a physical three-dimensional environment from a two-dimensional medium. But reality is more insistent than any trick. It ensures the chaos of the quantum world projects into stabilized forms. This is the reason patterns and layers form in the first place. Existence requires itself to become more defined, to turn projection into a physical event rather than a mere illusion. And what most misunderstand about this projection is that it is an ongoing process, not a strict transition. When a form becomes classical, the atoms, particles, and fields underlying the whole structure do not disappear. They become layered, but they are still there. All layers are needed for the structure to stand. Just as we need Pauli's exclusion principle for solidity and structure, we need the quantum world for us to exist at all, even through quantum decoherence, where a system loses certain quantum properties like superposition. The underlying quantum foam continues to pulse within that system, unseen but essential. Each projection does not disappear, it evolves. That is why reality stacks upon itself to build form. Each configuration is, at its core, a product of a chaotic soup of information entangled into stabilized structure. For information to grow and become structured, it must create layers of reinforcement. The reason reality feels compact, physical, and real is that it has to be for the projection to work. It is an illusion of the greatest order. Organized chaos arranged so that reality feels real. Because if the projection stays in the probabilistic soup, information cannot be truly perceived, known, or interacted with. The quantum world shows us this. Superposition and the uncertainty principle gives us layers of a fundamental confusion. It is only when reality projects itself into greater structure that information becomes precise, knowable, and predictable. So, is anything real? Is this a grand illusion played by the quantum world? If information is fundamental and matter is its derivative, are we living in a simulation? Yes, but no. Yes, in the sense that reality is not composed of things, but of relational properties of information exchanging itself into form. But no, because it is not algorithmic. Our current simulation models are all digital, deterministic, binary, and mechanical. But reality is probabilistic, not deterministic. The chaotic soup of information bypasses all of our assumptions of a neatly coded simulation. If we follow the pattern, reality is far greater than any mental model we can build of it. More dynamic, more creative, not merely mechanical and lifeless. It is filled with color and unimaginable forms. How fortunate are we to live in a world of such wonder and strangeness, to look up at the sky and see a billion worlds, to zoom in far enough to find a quantum realm that shatters our everyday intuitions. We live in an existence overflowing with activity and creativity. And if we track the pattern of projection, we can see that reality has a direction, from a chaotic soup of information to its macroscopic expression of planets and galaxies. Reality projects itself forward, engaging in the greater creation of itself, reaching always toward transcendence. Thank you, conscious colleagues, for lending me your ear. Today, we uncovered that the fundamental layer of reality is not built of things, but of information, and that projection is the mechanism by which that information becomes a greater, knowable version of itself. In part 2, we explore transcendence through projection and creation, and how it connects back to the entire framework. Thank you, and see you on the next episode.